Alright, so let's explore one of the most fundamental principles in electronics, Ohm's law. Whether you're designing circuits, fixing electronics, or simply curious about how electric current flows, this concept is a cornerstone of understanding electricity. By the end of this session, you'll master the law, its applications, and how it governs the behavior of electrical components. What is Ohm's law? Ohm's law connects three essential electrical quantities: voltage, current, and resistance. It states that the voltage across a conductor is directly proportional to the current flowing through it, with resistance acting as the proportionality constant. Mathematically, this is expressed as V equals I times R. Voltage is the driving force that pushes charges through a circuit and is measured in volts. Current is the flow rate of electric charge, measured in amperes. Resistance is the opposition to current flow, measured in ohms. Think of voltage like water pressure, current like the flow of water, and resistance as anything that restricts the flow, like a narrow pipe. Here's an example problem. If a circuit has a voltage of 12 volts and a resistance of 4 ohms, what's the current? Using Ohm's law, I equals V divided by R. Substituting the values, I equals 12 volts divided by 4 ohms, which equals 3 amperes. So the current is 3 amperes. Understanding resistance. Resistance is the property of a material or component that opposes the flow of electric current. Ohm's law assumes a material is ohmic, meaning the resistance remains constant as voltage and current change. For Ohm's law to hold, the resistance must remain constant, and the current must reverse if the voltage polarity is reversed. While most metals like copper are ohmic, some materials, like semiconductors, don't follow Ohm's law. Another example, a resistor has a voltage of 15 volts across it and a current of 5 amperes. What's the resistance? Using Ohm's law, R equals V divided by I. Substituting the values, R equals 15 volts divided by 5 amperes, which equals 3 ohms. Real-world applications of Ohm's law. Ohm's law isn't just theoretical, it's practical. In electronics, it helps design circuits with the correct voltage and current to prevent overheating. In household wiring, it ensures devices get the right amount of power. In automotive systems, it regulates components like lights and ignition systems. Here's another practice problem. A 9-volt battery is connected to a resistor with a resistance of 3 ohms. What's the current? Using Ohm's law, I equals V divided by R. Substituting the values, I equals 9 volts divided by 3 ohms, which equals 3 amperes. Power in electrical circuits. Ohm's law connects to power, which is the rate at which electrical energy is consumed or produced. Power is calculated as P equals V times I. For resistors, you can also use the formulas P equals I squared times R, or P equals V squared divided by R. Example, a circuit with a 6-volt battery has a current of 2 amperes. What's the power consumed by the resistor? Using P equals V times I, P equals 6 volts times 2 amperes, which equals 12 watts. Combining resistors. Circuits often have multiple resistors, and their configuration affects the total resistance. In a series configuration, the total resistance is the sum of individual resistances. For example, if resistors of 4 ohms, 6 ohms, and 10 ohms are in series, the total resistance is 20 ohms. In a parallel configuration, the reciprocal of the total resistance is the sum of the reciprocals of individual resistances. For example, if you have resistors of 4 ohms and 12 ohms in parallel, the total resistance is approximately 3 ohms. Ohm's law in action. Let's see Ohm's law in action. Imagine troubleshooting a circuit. By measuring voltage and current, you can calculate resistance to determine if a component is faulty. Here's a real-life challenge. A heating element in a toaster draws 5 amperes from a 120 volt source. What's its resistance and power consumption? First, use Ohm's law to find resistance. R equals V divided by I, which equals 120 volts divided by 5 amperes, resulting in 24 ohms. Next, calculate power using P equals V times I, which equals 120 volts times 5 amperes, resulting in 600 watts. The resistance is 24 ohms, and the power consumption is 600 watts. And that's a wrap on Ohm's law. We've explored its fundamentals, solved problems, and connected it to everyday applications. To dive even deeper into science and learn more, head over to kotc.me. See you there.